Okay, so we're doing AP Calculus AB Unit 5 test review, making a video of the last two free response, and if we have more time, I'll go and do some previous questions that we did in class today. Water is running into an open conical tank at a rate of 9 cubic feet per minute. Cubic feet is volume, minute, so it's going to be dV dt. The tank is standing inverted and has a height of 10 feet. And the base diameter is 10 feet. We're actually not going to use those numbers in our derivative calculation. Those are given to us in order to find the conversion factor with R and H. We have the volume of the cone formula. At what rate is the radius of the water in the tank increasing when the radius is 2 feet? Do you see how they used radius twice? That means we're going to want to rewrite our volume formula in terms of radius only. So we want to get rid of this height, okay? So based on that, the 10 by 10, we have to figure out, well, what would if the diameter is 10, then what's the R? R is equal to 5. So if R is 5 and the height is 10, then R is equal to what of the height? Is it twice the height? Is R 5? Is that twice of 10? 2 times? No. Is it 3 times? No. It's smaller, right? 5 is smaller than 10, so we're going to have to use a fraction or divide. So 5 is half the height. Let's double check this. Once I write it down, then double check it. Okay, if H is 10, does R equal 5? Yeah, it does. So because R equals 1/2 H, we're going to substitute. Hold on a minute. If I take this and plug it in for R, will I have R's in my equation? No, I'll have all H's. But we want R's, don't we? Okay, so let's think about this. We actually want to substitute in for H, so we need an equation that says H equals. Well, if R equals 1/2 H, then H equals what? How do I move that 1/2 to this side? Does H equal 2 times R? Double check the picture. 2 times 5 is 10. Okay, fantastic. So actually we're going to take these two R's and we're going to substitute those in for the H's and forget that idea. Ready? Get set. Here is our new volume formula. 1/2 pi R squared times H, but instead of H we're going to do times 2R. So we substitute, then we're going to simplify. The 2 I'm going to put in front with the 2/3 pi. And then R squared times R is R cubed. There's my simplification. Okay, ready? We need to take the derivative. So derivative with respect to time. Take the derivative of the entire equation, and we have dV over dt. Now let's see here, 3 comes down in front. Oh, we like that because the 3 cancels with this 3, and we're left with 2 pi r. Don't forget to subtract 1 to get a power of 2. And then since r is different than the denominator, sorry about the lights, it will adjust, then we're going to say, then we have to multiply by the derivative of r with respect to time. dr dt, like that. All right, now it's time to fill in some values. 9 cubic feet per minute. Cubic feet is volume, per minute is a rate. So 9 is dV dt. 2 pi, and the radius. Now it's a little confusing because here I say radius is 5, but then the question says radius is 2. So you got to think, is the water all the way at the top? Is the radius of the water 5, or is has the water been drained? Or is it increasing and the radius is 2? We're talking about the radius when it's 2 feet. So I encourage units, but I forgot about them over here. My apologies. And are we trying to find the rate of the radius? Good. So we're trying to find dr dt. Okay, we're going to rearrange this to get dr dt by itself. And I'm going to do that over here. So dr dt will equal, we had a 9, and this was 9 cubic feet per minute. And we're going to divide that by 2 pi times 2, so that's 4 pi feet squared. And is this calculator or no calculator? It's no calculator, so we can leave this as 9 over 4 pi. Don't bring the pi up, and the feet, 2 of the feet cancel, and we're left with feet per minute. And that's our answer without a calculator. All right, good job. This is a free response with an implicit, but remember on the test, the free response will actually be a particle motion, so position, velocity, acceleration, but this is still good review for our multiple choice. Scan your problem. Will you have a product rule? No, 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 no. No product rule. That's nice. And we have the answer here, so we just have to make this look like this answer. So declare to the world you're taking the derivative with respect to x, not time, x, and the derivative of x squared is going to be 2x, derivative of 2x, 2, derivative of y to the fourth, 4y cubed times dy dx. Derivative of 4y is 4, dy dx. The derivative of 5 is 0. We leave the dy dx terms on the left side, and we're going to move these terms to the right side by subtraction. What do you notice? Do we have a common factor going on here? I see a common factor. You could take it out now, or you can wait till the division step. Negative 2x minus 2. In order to move these to the other side of the equal sign, we have to subtract. Now I'm going to factor out the dy dx, and when I do that I get 4y cubed plus 4 equals negative 2x minus 2, and then we take the parentheses and divide it to this side. Dy dx equals, if it's okay with you guys, I'm going to factor now. So I have negative 2, I'm going to factor that out of the numerator, leaves me with x plus 1. All over, and the common factor here is 4, so I'm going to factor the 4 out, and I have y cubed plus 1. And there you see 2 over 4 reduces to negative 1 over 2. And let's double check. I have a negative x plus 1, 2 y cubed plus 1. So, ta-da, I did it. I checked. I showed all that work. Find the equation of the line to the curve at this point. So to get an equation of a tangent line, we need a slope and a point. And we have a point, so our slope is going to come from the derivative. I think I need to move up. Yes, here we go. So what's the derivative evaluated at this? Do you see why they gave us the answer to the derivative here? Because you wouldn't be able to get B right if you got A wrong. So we know that this is the derivative. Don't use your answer, use the one given on paper, just in case yours was wrong. So minus x plus 1, what's our x value? Negative 2, negative 2 plus 1, 2 times y is 1, so y cubed plus 1 equals, I have a negative in front, I have a negative 1 on top, but those cancel, or negative and negative make a positive. And then 1 cubed plus 1 is 2. 2 times 2 is 4, so I have 1/4. That's the slope of the tangent line, so the equation will be y minus 1 equals 1/4 times x minus negative 2, which turns to a plus sign, and that's it. That's the equation of the line. Eek. Okay. Find the coordinates of the 2 points, thank you for telling me there's 2, on the curve where the line tangent to the curve is vertical. So a vertical tangent line means the derivative is undefined, and we're going to set the denominator of the derivative equal to 0. And to do this, we're going to divide by 2. And then we have y cubed plus 1 equals 0. Subtract 1, y cubed equals negative 1. And then take the cube root, which we can do, and y equals -1. And then you should think, that's only one answer, but the question says 2 points. So, but we still need our x's, right? So we could plug -1 for y now into the original and find x's. And I see an x squared here, which means it's a quadratic, which quadratics usually produce 2 answers. Okay, you ready? Here we go. X squared plus 2x plus y to the 4th plus 4 times y equals 5. -1 to the 4th is +1 minus 4 equals 5. We need to get this all into one side. So 1 minus 4 is -3, but then I'm going to subtract the 5. So our quadratic equation, I'm running out of room, is, what's that going to be, -8 equals 0. All right, we should be able to factor this. So what multiplies to get -8 but adds to get +2? Is that going to be x plus 4 and x minus 2? So x equals -4 and +2, and the question says, what are the 2 coordinate points? So here's all my work, and I'm just trying to find a place to write my answer. I'm going to put it up here. -4, -1, and 2, -1. Once you find those, you should have completely forgotten as to what the heck we were trying to find in the first place. So we were find the coordinates of the 2 points on the curve, or the line tangent to the curve is vertical. Remember your vertical asymptotes? So to find a vertical line, we set the denominator equal to 0, but because it says tangent, we're setting the denominator of the derivative equal to 0, which was this. This was in the denominator of dy dx. So we set that equal to 0, found a y, it says 2 points, so we had to plug it back in to the original to find 2 x values, and those are our 2 points. Definitely not easy. All right. I said if we had time, I'll go and do these. If you don't need help with these, then way to go. Good job. Let me look at 20, okay? Because a lot of kids did 18 in class. The radius of a sphere is decreasing at a rate of 2 centimeters per second. At the instant when the radius of the sphere is 3 centimeters, what is the rate of change in square centimeters per second of the surface area of the sphere? The surface area of the sphere is this. So first thing I'm going to do is I'm going to write that formula down, and then I'm going to take the derivative with respect to time, and either I could solve it or I'm going to have to do more work, okay? So the derivative with respect to time, I need to take this 2 down in front. So 2 times 4 is 8 pi r times dr dt. Now let's see if we can fill this or if we need to do more work. The radius of the sphere is decreasing at a rate of 2 centimeters per second. All right, that's dr dt. The instant when the radius of the sphere is 3 centimeters, that's r, what is the rate of change in square centimeters per second of the surface area of the sphere? That's ds dt. All right, so we're good. ds dt will equal 8 pi r was 3 centimeters, and dr dt. Now, what do you do when you see the word decreasing? We need to have a minus sign. So minus 2 centimeters per second. And we get 8 times 3 times -2 is -48 pi centimeters squared per second. That is the rate that the surface area is decreasing. It's negative. Okay. Real quickly, you can see the cube, the derivative of the cube, and we put in the values, and it looks like we have -24. 4 squared is 16. 16 times 3, 16 times 3, 48. 48, but we're trying to find dx dt, So we need to divide